Discussion. I think the first thing I'm going to do is actually going to talk about a couple reactions of aldehydes and ketones that I talked about within our half class that they undergo, just so everybody's on the same page. And then afterwards, obviously, if you have any questions, I'll be happy to sort of answer those for you. So I just want to kind of go back to aldehydes and ketones for a second and talk about a couple of reactions that they do sort of form with alcohols. So a reminder that our aldehyde has the functional group that looks like this guy. And again, our ketone has the functional group that is really the 3 carbons in a row with a double bond there in the middle. So for each of these guys, if you add 1 alcohol or 2 alcohols to them, they will undergo did it do it again? No, somebody should really download this thing. All right. We'll save it for somebody else, I think. All right. So if they sort of add 1 alcohol to an aldehyde or a ketone, you will get a certain class of compound that we'll see a little bit later on in sort of carbohydrates and those type of things. And if you get 2 alcohols added in, you'll get something else. So we'll first look at the aldehydes and an alcohol. So what we're going to do is basically take an aldehyde. We'll take any aldehyde here. And if I take an aldehyde and I add 1 alcohol to it, and again, it could be really any alcohol, but we'll take this guy here. It's going to really do an addition reaction. So if you remember, an addition reaction is when we actually add 2 things in, and it's typically to a double bond. So in the case of the aldehyde, that really is where sort of everything occurs. So it occurs pretty much right here at the double bond. So kind of, if we think back to just the basic alkene that we started talking about way back when we do an addition reaction, if we add anything to it, HCl, water, or 2 hydrogens, 2 bromanes, it all happens right here at this double bond. And as we talked about, what we have to do to double bond is really make it a single bond to allow room for everybody to come in. And that's essentially what would happen in this case. That double bond would become a single bond. Everything else would stay the same. And the addition means that basically 1 of these guys go to 1 carbon and 1 of those guys go to the other. And in this case, it really doesn't matter which one. So when we sort of do this reaction where we add an alcohol to an aldehyde or even a ketone, as we'll see in just a second, it's really the same sort of reaction is taking place. So right now, as it stands, where I boxed in the aldehyde, it pretty much has no more room. Everything is filled. And again, a reminder that although organic, we don't really draw it a lot in this sort of class, but there are non-bonding electrons on the oxygen. So it's filled really at this point as well. So we got to do kind of the same thing. We're going to add the alcohol to actually the carbon-oxygen spot. And how the alcohol adds is basically 2 things. It adds with this sort of oxygen-carbon group, which is actually more negative. And the other part adds as the hydrogen, which is actually more positive here. And if you remember that the OH bond is negative on the oxygen, positive on the hydrogen. So that is sort of how that works. Now, to allow us to do that, we need to basically redraw this entire thing exactly the way it is, except that we're just going to make, just like we did with the alkene, our double bond into a single bond. So if we redraw this thing exactly the same way, I'm just going to go below it to give me a little bit more room. Nothing's going to change except that I'm now going to basically just make that into a single bond, just like we did with the 2 carbons. And we're going to still have our H hanging out there. what we've now done is basically made room for each of those things to go in. And if you remember today and before as well, we talked about the carbon-oxygen double bond, that it is polar, and it's the carbon that's more positive, and the oxygen is more negative. So what happens in this case is opposites attract. The hydrogen part of the alcohol will go to the negative oxygen, and the oxygen part of the alcohol, this oxygen carbon part, which is more negative, will go to the more positive side there. So that's where they both end up. The result of that is the hydrogen would be added over here from the alcohol, and that oxygen carbon group would be added right there from the other part of the alcohol. So what's in green is the alcohol here. Basically, it just got added on. First off, any questions on that? So it's very, very similar to the carbon-carbon double bond, where we make a single bond and kind of put everybody one on each side. What we just made here actually has a special name. It is what is known as a hemiacetal. This is what is referred to as a hemiacetal. Now, you can remember it this way. What makes up a hemiacetal is the hemi part, OH group. And there is a oxygen carbon group, and there is a hydrogen. So those three things all attached to the same carbon is what makes something a hemiacetal. It's got to have the OH group. It's got to have that oxygen carbon group that came from the alcohol. And because it really came from an aldehyde, it will always have that hydrogen there still hanging out because it's from the aldehyde part of it originally. Any questions on that? So if you add one, yeah.
They don't add the lines?
Yeah, you could, you mean on the bottom here, right? And add the line. You could add the lines, it's fine. You could do it either way, it's okay. Yeah, you can't, yeah, so you could, if you want to put the lines in, you can. You'll sometimes see it both ways, without the lines or with the lines, but you can put the lines in, definitely. Technically, without the lines, it's really what is referred to. It's just condensed formula. With the lines, it's what is known as a condensed structural formula, kind of with the little dashes in there. So kind of the same version, but you can do it actually either way in this case. Other questions? Okay, so one alcohol to an aldehyde will produce this compound, which is known as a hemiacetal. If you actually add two alcohols to that aldehyde, the first alcohol will make this guy, and then the second alcohol will actually build off of that guy. So I'm just going to redraw my hemiacetal here, which is what we get after we add the first alcohol to it. And if we added one more alcohol to it, and again, it could be the same alcohol or a different one, don't really matter. A similar sort of thing is going to happen in terms of the alcohol. So the alcohol is still going to have really its two parts, just like it did before. The hydrogen being more positive, the oxygen being more negative. And it is going to add basically in these two parts, in a sense, just like it did before. Now, what happens in this case is there's actually no double bond to break anymore, but we still need to sort of put some stuff on there. So to make room for this, what's going to actually happen is we're going to lose water. And you can think of it like this. We always make water from H and OH. So just like we did before, we're going to actually make water from those two things. So these two things are going to basically make water. And when I do that, what that's going to do is actually make my carbon down here still going to be positive. So once that water is removed, the oxygen carbon group will come right behind and basically attach exactly in that same spot. So kind of like it did on the bottom, it's going to attach there on the top once the water basically makes room for it. And again, nothing's going to change. So 100% of everything that is here still stays there. So just copy it exactly the way it is. And once again, I'm going to do it a little bit below to give you a little bit more room. We're going to go here. And again, everything in the box there will be exactly the same. And now this part has a spot to go onto the same carbon. And we're going to add one more of those sort of oxygen carbon parts right there. So it's going to come in from behind after that water basically leaves. And it's going to go into that exact same spot. So what we end up with here is something where we basically added two parts to it here, these oxygen carbon parts from two different alcohols. So they're basically the oxygen part of the alcohol. And this is what is known as a acetal. So no hemi because the OH group is gone now. So this is an acetal, which is what you get when you add two alcohols to an aldehyde. The major parts of it is actually two of these oxygen carbon groups, and still the hydrogen is still there. So you got two of these oxygen carbon groups, which both come from an alcohol, and that hydrogen still there, and that's an acetal. So if you add just one alcohol to an aldehyde, you get a hemiacetal, which still has the OH group. And then if you continue to add one more alcohol to it, it will take out basically the OH to make water, and then the rest of the oxygen carbon will take its place right there. Any question on that there? So if we look at one here, if we took, and again, it doesn't really matter what your aldehyde looks like. It could be small. And we could take our alcohol here. Make a nice small one. Again, if we add our first alcohol, we're going to make our double bond into a single bond to make room for the addition. And once again, this guy will end up at the carbon. The H will end up over there at the oxygen. And we will end up with an H up there and our oxygen carbon group, which once again will make our hemiacetal, which has that OH group, the H, and this oxygen carbon group as central to it. Again, adding one more alcohol to this will take us all the way across to sort of the finish line, if you will. And we will get, at this point, this and this will come off to make water. And once again, everything here in the box stays exactly the same. And basically, we've already taken care of that and that. That leaves just this left, which will find a spot kind of opposite of the other guy there to make our acetal, which once again is two of these oxygen carbon groups. And again, steal that hydrogen that is there. Any questions on that there? Now, this reaction basically occurs the exact same way with a ketone, except that you are missing one little thing that you do have here with the hemiacetal or the acetal, which is actually that hydrogen. And that's because when you start with a ketone, you actually don't have the hydrogen on the carbon. So let's take a look at what happens if we do this exact same reaction here with a ketone. So we'll take any ketone, and again, a ketone looks something like this. And if we added an alcohol to this, it will work the same way. We need to make room for it, so it's all going to happen right there. And we're going to turn it into a single bond to make room for it. And once again, our alcohol will add just like the other alcohol did. And again, it adds in two parts. In this case, it's the H. And that oxygen carbon group with this guy being positive, negative, again, negative and positive here. So our positive hydrogen will end up there on the negative oxygen. Our negative oxygen will end up on the positive carbon there. And we will add this guy here. And again, it looks exactly like what we drew a second ago. This actually has also a special name. This is what is sometimes referred to as a hemiketal. It's a hemiketal because it started with a ketone as opposed to an aldehyde, where the other one's named an acetal. It has really the same functions or same groups as the last one. It has an OH group, which is sort of the hemi part. It has an oxygen carbon group. And the one thing it does not have that's different is there is no hydrogen here. So unlike what we see with our hemiacetal, that the hydrogen is there, and a hemiketal that starts with a ketone, because we don't have the hydrogen to begin with, it does not come in at the end either. And just like what we did with the other one, this guy can then accept one more alcohol the exact same way. And again, if we add another alcohol to it, once again, the alcohol will add the same way. So we have this oxygen carbon part, which is really more negative. We'll have this guy, which is positive. So it's going to be the OH and this H that's going to come together to make water. And just like what we saw on the previous one, everything that's left over at this point will basically stay the same. So nothing will change. So you could just copy it exactly the same. And again, we just have CH3, C, CH3, O, CH2, CH3. And now if you think about it, we took out water. So that leaves just what's in the box to end up on top. And this is what is known as a ketal. So kind of like the other one's an acetal. This is sometimes referred to as a ketal. Again, some people will call the top guy a hemiketal and the bottom guy a ketal. The ketal has two oxygen carbon groups. And once again, no hydrogen on the carbon that's there. Now, some books, and your book might be included as well. Some books, including your book, may also just call these guys a hemiacetal and an acetal as well. They may not make the distinction between hemiketal and ketal. But some people will make the distinction. If you start with a ketone, you'll end up with a hemiketal. If you add one alcohol, that'll have the OH. If you add two alcohols, it'll go all the way to a ketal. Question on those reactions there. So they're very much like the addition reactions to the double bond, kind of making room for it. Any questions on that? Okay, I just want to go over those with you like I went over it with the other half of the class, so everybody's on the same page officially. All right, is there any other questions or anything I could help anybody with, stuff that we've been talking about, or what we just talked about here? Yeah, so it would go with the aldehydes and ketones, which should be chapter 12? No, 12 maybe, I think, actually. I think it should be 12, actually. Other questions? Question on anything else I could help anybody with? No? Okay, so for the rest of the time, we're